So in this video, we're going to talk about these 4 games. And I'm sure with these 4 games, you'll be able to understand a lot about the computational thinking. And the first one we are going to cover is the face-off. She's my daughter Nikisha, and with these photographs, you can see she has a very sporty kind of attitude. So she wanted a game and she asked me to give her some new game. And so I created this game for her, the face-off. And I'm sure you will love this game. And what I was just trying to do with this game, I was trying to decompose the human face and was giving her an opportunity to create new kind of faces. So you can see here we have created these eyebrows and these 2 different kind of eyes and a little bit of different mouth or lips, whatever you say. And then these things, this decomposed face of a human, I gave it to my daughter Nikisha and asked her to create some new faces. And she made this, and then this, and then this. So you see, I was not expecting that she will make mustaches out of it, but she did. And she started liking it. And soon she started realizing the different expression on the human face. So kind of exclamation or happy in the right image or some sadness in these ones. So she also started recognizing the moods on the faces. And she was literally loving it. But then she told me something that was very exciting for me. She told me she was not able to see herself in this face. She wanted something extra. And so I provided. And she made this. And then this. So you see, with a little dingling things and the nose, she was able to make better new faces. And these were the feminine faces. And she was liking it more. Because now she was even seeing some kind of image of herself in these pictures. And what she was learning, if you realize, she understood that the human face can be decomposed, and she also was learning about abstraction, because there are many other things in a face, but we were using a bare minimum thing from a human face and were able to create faces. Isn't it? And then she was able to understand the pattern. So what kind of lips makes it a happy thing? What kind of eyebrows make it a happy thing or sad thing or angry? So she was able to recognize the expression or the patterns with this game. And I was loving it actually, the face-off. So after face-off, the next game is the pixels. And let me tell you, this is a very nice game. And it is inspired by a CS Unplugged activity. So let me show you. So this is a shape that has been made on a square copy that we use for doing mathematics in young classes. And if you see it closely, we have tried to color a few squares out of the entire square copy to create a shape. And we have actually tried to replicate a shape of a rocket, maybe a flying rocket, you can say. So what we are trying to do? We are trying to tell young kids that using these squares and coloring them, you can virtually create any kind of shapes that you are watching in the real world. And here is the question for you also. Do you really see a rocket? And if you see that in the same fashion, the kids are also able to see this whole thing. And let me show you some other shapes also and how kids react to these things. So this is a actual replication by my daughter. So I created this orange kind of rocket shape and she replicated it with this red and blue and yellow kind of shape. But what she was doing, she was actually creating a rocket. Then I created a mug, a coffee mug maybe, or a tea cup, whatever you say. I created this blue tea cup and she replicated it with colored things. But what she was actually doing, she was coloring squares. And I'm sure by this she was understanding that she can create different shapes by coloring the squares. And I can still recall this was kind of a hobby then for her, as she started creating many things that she could find inside the house or outside the house, and was trying to make all those things using squares. And this is the way exactly you can teach them the concept of pixels. And that is the first level. But I wanted to do something more. So I went to the next thing and I created this game. Now in this game, what we do, we take again this square copy, and on the left side, I chose a few squares, these small squares, and colored them with different colors. And then I asked my daughter to replicate the same design that I have created on the left side to create it on the right side of the copy. So then she was watching one at a time and doing the same thing, and another and the another. And then for a very young kid, it was not easy. It was not easy because she might miss one square or two, and replication itself was not that easy a task, which could be looking mundane to you. It was a tough thing for a very young kid. She was, I think, 5 or 6 at that point of time. So what I did, I said, why not you start writing the numbers of the rows? So you can see in the right hand side of both the pages, there are numerals written 1, 2, 3, 4. And this was to help her so that she do not confuse one row with another. So now she was able to see that it is the first row, and in the first row she has to do which number of square red, or which number of square blue, or which number of square the other color. And that way she replicated the entire left page on the right side. And now the game started. So what we were doing, once this replication was done, now I will ask her to move her face to the other side, and I will color any one of these square in the left side in some color. And then she will look back and she have to find that one new square that has been recently painted, and then she will replicate it at her page, and then I will face the wall and not watching this page, and she will do the same process on the right page, which is her page, and then I will look back on the copy, and then we'll try to find out this new colored square, and then do the same thing on my left page. And then we were playing until it becomes very cumbersome to play anymore. And this was a game both of us were loving. Now let's come back to the same picture. This, do you see a rocket? Now imagine you want your daughter or your son to replicate this same image at some other page, but without watching at this thing. And let's create an algorithm for this to give it to her. And this is a very specified standard CS Unplugged activity that I have taken. And this is wonderful. Like you must try it with your kids. So what we did, we created this. Now you can see it is showing 9, 3, 7, 5, 6, 2, 1, 3 and so on. Now this is a code basically to let kids create that shape. Let's just see, 9 and 3 is the first row. So let's go back. So if you see, we are doing 9 squares in the first row from the top. 9 first squares are blank. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 3 are colored. 1, 2, 3. So let's come back here again. 7, 5. So we can see now this time 7 in the second row. 7 blocks are blank. 1, 2, 3, 4, 5, 6, 7. And then 5 are filled. 1, 2, 3, 4, 5. Then let's go back. 6, 2, 1, 3. So that means first letter tells us how many blank spaces. So this is 1, 2, 3, 4, 5, 6, 6 blanks, 2 filled, 1, 2, then 1 blank again, and then 3 filled. So the first letter represent blank spaces, then filled spaces, then next for blank spaces, then next for filled spaces. And this way we can tell our kids to replicate the entire image by an algorithm. So we just have to tell them that this first line is that they can use these numbers in its same order. The first line represents the first line on the image also, and in the same way it can be done. And if you see in the lower 5 lines, I have been using minus thing also, because when I started creating this whole thing, the reference was taken from one point and I realized the image was even going left side from that reference line. So that way I have to take this minus thing, but I will strongly recommend you to create images in the beginning if the kid is very young, not to use these minus things. Always take the leftmost side as the reference so that you do not have to use the minus line. And then these young kids will be able to replicate these images even by a code, an algorithm. Do try to create a few such images and see what is the result, how kids are responding, and I'm sure you will love this activity and they will also love this. And if you go on CS Unplugged, you may find a few more such activities and you should try to play it with the kids. And this one game, you can play it with kind of very young kids and then possibly move to the next level. So the next game is tables. And this game we played when my daughter did not know what is a table. So what I did, I put the numbers from 1 to 100 in this format where we have put them in 10 columns of 10 numbers each. And in this array, I wanted to plot the tables and I wanted to see with her how this will get plotted over here. But my daughter by then does not understand plotting, does not understand tables. So what I did instead, I said, Niku, can we do a game where you will add one number with itself again and again, and whatever is the addition, we will mark it on this array. And we started with 9. So we plotted 9 and then 9 and 9, 18. And then she did another addition, 9 and 9 and 9, 27. And then 27 plus 9, 36. And then 36 plus 9, 45, and so on. And she was loving it because when she was adding the same number to itself, it was coming in a ascending line. And then she wanted to do such a thing with other numbers too. So she asked, Daddy, so what will be the next number? And I said, let's do it with 11. And so this time we did 11 plus 11, 22, 22 plus 11, 33, 33 plus 11, 44, 44 plus 11, 55, and so on. And she was so happy. This time it was a descending line and she got a curiosity. And if you realize, the job of an educator is to harness curiosity in the mind of young kids. If we can give them inquiry, if we can give them curiosity, that is the right kind of education, isn't it? So she was liking it and she asked me, so Daddy, if we do this operation with any of the number, we'll get ascending or descending lines. And she was obviously not mentioning ascending and descending. She was saying this kind of pattern. And I said, I don't know. So let's start doing it with other numbers. And then this time I took 5. And then we started plotting 5, 10, 15, 20, 25, 30, 35, 40, and so on. And this time what we saw were 2 parallel lines. And in this way, I started telling my daughter about the tables. And she was liking the concept of tables, while she was not knowing what is a table formally. And the possibilities are endless in this game. You can do many things and can keep observing amazing things in this game. Now let's move to the next game, which is called the active algo. And frankly, we can create any number of such games, and the whole idea is to create a library of such games and activities for the parents and teachers, so that we can work with the young kids and can provide them with an opportunity to solve new problems with computational thinking. So this new game is called the algo games. And why algo games? Because in these games basically we are trying to teach the kids the importance of sequencing and how whatever they have observed, whatever they have identified as a pattern, and whatever abstraction they are trying to do, how possibly they can sequence the order of the action and how important is the order. So I'm sure you must have heard that Simon Says is a famous game we play with this very young kids, and in this game you say Simon says this and you give an instruction and the kid will follow that instruction. So you say Simon says take 2 rounds and run to that table, pick up that thing and come back, those kind of things. So I was also playing the same game with my daughter. So in this game she has to make some rounds and then go to the other room and then eat an almond and then come back. So that was the sequence. She did it perfectly, and then I asked her to write that whole structure, whole sequence on the board. And she wrote it very nicely. You can see the picture where she has actually written those things. And now I asked her, so Niku, if I replace almond with a banana, what will change in this sequence? And she thought about it and she said, okay, we will just replace almond with banana. And I said, are you sure? And she said, yes. So we did it, and then I said, okay, let's execute it. So she did it again. She took the round and then ran to the other room, and then she was about to eat the banana and she started peeling, and I stopped her. And I said, no, you cannot peel the banana because you haven't written it over there. And then she understood, oh, that way. So she went back to the board, she introduced one more step, peel the banana, and then came the next, eat the banana. And that ways we were able to close this entire algorithm. And with this whole idea, she was able to understand the concept of sequence. And there are many new games, many new things through which you can teach this importance of sequencing. So the whole idea of my works on computational thinking is to get more and more such activities and games so that I can help many school teachers and parents to help their kids think computationally. And that way only I wrote a book so that I can extend all these ideas to these people. And now I'm looking for some contributors into this book. And in case you want to become one of the contributor for my upcoming book, you can have a look at my next video through which I'll try to tell you how you can contribute to my works. Thank you.